I'm going to be speaking to the camera first. Hi, everybody. Sorry we started really late today. We were having technical difficulties. This is the first time that LA Jug will be running on Google Hangouts on air. We'll be streaming this live, and then later on, it'll be available on YouTube. So welcome to the Los Angeles Java Users Group. This month's presentation is Open Source Enterprise Service Bus by Fred Abedi, the CTO of Logicboy, is how you pronounce it. Our meeting always starts off with certain announcements that we always make. So first of all, are there any announcements to be made before we begin the meeting? Yes, what's your answer?
I'm here checking on the forward managers of the Java User Group, June 12th. We're having a presentation on Cassandra. So for data, Cassandra, it's in Irvine.
Thank you.
Is the Hangout open?
It's open.
It says.
If you go to the LA Jug website, you should be able to see the link. Any other announcements?
Ken's not here. We have a reading group. It's on Tuesdays when this meeting is occurring. It's really far away. It's one floor up. Because you need an escort to get in, we meet at Starbucks at 7:30. The RESTful Web APIs. RESTful Web APIs. Rewriting the book 7 years ago. The author finally got it done. So we've got lots of experience. The book is really a how-to guide to design and build RESTful APIs. It's not just here's how you recognize one. It's how you actually get there and have one from scratch. And introduce this to people I'm working with. We're actually moving in that direction. It's really awesome. We're on chapter 7 and 8 next week. But don't worry about jumping in late in the book. The format of the meeting is that we kind of go in order of having comments on the chapter. We kind of keep a paragraph. Some people spoke about even having a book. But discussions are still interesting.
Okay, we're short for time. Okay. Any other announcements? No. Anybody looking for a job? No? Anybody has jobs that would like to announce? Sure. Make it short and sweet.
CMF has openings.
Please talk to them. Anybody else? Our host? Thank you.
Thank you for listening.
So now we will proceed with the presentation. I will make it part of, where is it? So it's screen sharing. And enjoy. Okay, if you're going to disconnect this and do you know how to find this thing? There's a 5 minutes.
All right, so sorry about this. And my name is Fred Abedi, and I'm going to do a presentation on OpenESB, which is an open source enterprise service bus. First, a little bit about our company. We were founded in 2009, providing IT collection services in ESB, middleware, and so on integration projects in insurance, financials, telco, healthcare utilities manufacturing, government markets. We have offices in the US, UK, and India. And, consultants in France and trying to open an office in France also. Basically, our background is we're architects and development managers from Sun Microsystems. Myself as director of that Sun Microsystems for the middleware products, open source middleware products. And,
It the computer probably better.
Okay. All right. And then, so basically, if you've heard of Glassfish Application Server or Glassfish ESB and possibly Java Caps, those are the products I developed. And we are the primary vendor that provides support for OpenESB. And there's an open source community. You'll see details of that where you can contribute. So these are basically, our basic services that we provide. I'll zip through those. But talking about software evolution, what is it that especially when you do integration or ESB, what is it that really costs more? Is it really developing software? No, it's really maintenance, especially with integration projects. There's a lot of ends that have to be maintained and change. It's not just monolithic software that you write. There's a lot of changes all the time, with different pieces of software happening, and you want to make sure that the dependencies are low and the maintenance becomes low. So basically what we're talking about is how much is development, how much is for integration, but really about 80% of it is for maintenance and evolving the project. And so because of that, we have to reduce the cost. And how do you reduce the cost of the IT infrastructure for integration projects? You can think of, I'll give you some examples, and then maybe we can use an example of like a project like that and how, what are the costs when things change. So you can think of an example of a bank transfer. And let's say you want to do a bank transfer, and the business process to do a bank transfer could be receiving a transfer by some sort of a request, and it could be a web app, it could be a mobile app or whatever, some sort of email. You have to obviously check the rights, you have to check the account, you have to do a validation, and then possibly do a Swift wire transfer if it's overseas. And you have to obviously log this transaction, and you have to send the confirmation. So, this is like, obviously, for a real integration, it's a lot more involved than that. But for just this purpose, even a simple thing, imagine what could be involved in doing that. And so, let's say the infrastructures involved are, Oracle databases, maybe IBM mainframe, handling some part of it. The validation part could be a person doing some approval or something, and then obviously there could be if it's a transfer, some sort of interbank transfer that would happen. That could be another entity, and then you have to log that somehow, obviously. So all of these things have to work together, and the communications between them could be different. The mainframe has to talk to Swift, for example, and pretty much, if you can think of, the connections between various pieces of this application, over time it could become exponentially high. especially as we make changes. So basically, there is going to be a lot of links to manage and maintain. And it could be like, how is it, what is the protocol to talk between the mainframe and the Swift? Do you invent that every time? So you want to keep that dependency low so that the impact is less. So going through all of these different things, you can see how expensive it can be. And if let's say you introduce your CRM or ERP into this mix also, like SAP, and that for each of those, then there is more connections to maintain. So modifications becomes really, hard. So for this, you obviously want to reduce the knowledge between the components and reduce the dependency and maintenance. So how do you do that? You can do it by reducing the coupling and decreasing the dependencies. And in a standard way, how is that done? Contract of services, intermediation, and process externalization. So you can imagine in a normal way, you have one application having the knowledge of another application, right? Now, if you think about that knowledge, what is it? Is it Java classes, functions, protocols, parameters, security, all of those different things, kind of things that the application has? You don't necessarily want to have all of that dependency there. So what do? You encompass that into a contract. So the dependency remains inside the contract and not directly within each of the applications. And when we talk about a contract, of course, in this case, a technical contract, right? But there is other aspects of it which we don't care about. So for contracts, obviously, there is also the thing is, as things evolve, versions of different services, you also want to make sure that these versions will make the applications immune. So somehow, you can have a newer implementation of the other end without causing everybody to change. So as you can tell, the technical contracts can have, things like parameter types, protocols, and security, and things like that. There are obviously several kinds of technical contracts, CORBA, IDL, Java, C# interfaces, web services interfaces, WSDL, web services description language, which is a standard. And then on the WSDL contracts, you can have standard XML. WSDL is good for integration. So just some comparisons between a WSDL and Java interface. As you see with WSDL, with the Java interface, you have obviously a dependency on the on the actual interface itself, client, between the two applications. With a WSDL, you sort of abstract that a bit. So the agreement is really not between the two; it's really the WSDL itself. And the two applications don't have a direct agreement.
Sorry, I realized that something's wrong. Sure. Which one is
This one? Yeah, that's the one. Oh, it's not showing that.
see when you go to full screen?
Okay.
It's not showing up in Hangouts. That's weird.
We can show it without the full screen.
Yeah, I think that'll be better. What's another way of viewing it? It's just a slideshow, right?
Yeah.
No, in the Hangout, it's just showing this screen. Why is this slow? I don't know what this screen looks like. Alright, just proceed. I'll find a way to fix it. This is becoming a disaster.
That's the first time for Hangouts.
Well, ideally there would be two screens. So and the computer's going crazy on this. I know what I should do. Just do a desktop, yeah. So screen share. And then, okay. Okay, let's see. Continue.
Fred, can you amplify that point? The difference between
Java interface and WSDL.
And WSDL, right? Because from practical standpoint, we're using it, we're just using basically the Java binding, and it completely hides the WSDL.
No, so you do not use the Java binding in the WSDL. You have to actually have, and when you actually do a project, you'll see there is in the WSDL you can define your input-output, you can define your binding, and it could be an abstract or a concrete binding, but in the case of OpenESB, you can actually use what is called a late binding, which basically you abstract the binding, you don't even define what your endpoints are.
I think he was talking about code binding.
Right, code binding.
Right, he's talking about using Objects-D or something.
Right. Well, that is obviously if you're doing that, you don't really have a contract because you really are. It's introspecting your Java classes and you're making access method. You're creating accessor methods to your Java interface, Java API. That's not what you want. With WSDL, you don't. If you're using WSDL, in this case the components actually implement. Just work with the WSDL interface and nothing else. They don't have any knowledge of the Java bindings or anything else beyond that. In fact, it doesn't even have to be. Your other end doesn't have to even be Java.
To the right side.
Yeah.
That way the people.
Yeah. So let me. I can. I'll actually go later on. If you give me a few minutes. I'll show you what a WSDL looks like, and we can show the difference right there. So in a later point, I'll show what a WSDL looks like, and we can actually. So this is talking about intermediation. So you have application A, instead of sending it directly to application B, send it to an intermediate. And then let intermediate worry about the routing and other things. What does it do? It couples the two partners. And a bus architecture is actually a really good way to decouple them. So what does a bus do? It allows partners to connect up to the bus, components to connect up to the bus. And it does a message transport. It can do routing. Now, remember, all of this that it does, the clients, the components that are hooked up don't have to know what will happen, because you can configure that in the bus. And you can also do message transformations. And obviously, you can allow multiple addresses to be handled by one, for one message. Now, imagine if you had the point-to-points like we were showing before. If a change was happening, everything would be affected. Now, in this case, nothing is really affected other than some configuration, maybe. So it's a good intermediate. It allows for application decoupling and other things, and it allows you to do other things too. And we'll discuss that in a later point. So you can think about when a change happens, like adding a new communication channel, or modifying a business process, or modifying a data structure, or adding a new client to an application. Any of those changes in the old way, where applications had knowledge of each other without a contract, would be catastrophic, would be really a lot of work. So in this case, let's say you want to add a new channel. So right now, you're having some HTTP invoking the service 1, right? And you're adding and some FTP process, and maybe some WebSphere and queue, all using services of 1, maybe some kicks, and all of these different protocols would be would be able to be handled by the ESP without actually writing any kind of code, because you could just use the components that are part of the ESP. So in a process where you have the services strung together one at a time, like in a series, there is no orchestration. Service 1 would have to know that it's sending to service 2, service 2 would know that it's sending to service 3, and so forth. But when you have a bus, you don't have to know that. You're all hooked up to the bus. All the services are on the bus. Message coming through the bus can flow through them. And then there is an orchestrator. And we can talk about what is an orchestrator, orchestration engine, in a few minutes. But the orchestrator would be then the person who would be responsible to do this orchestration of the messages going, or the services going to that. So if you're going to introduce service 5, in this case, you don't really have to change any of these other services. You don't have to change service 4, for example. Right? All you have to do is tell the orchestrator that now there is another service. So I imagine service changes from one version to another, or you need to do some data transformation. We can do that without really doing any other changes. You can hook up the XSLT component, or data transformer, or rules engine, like rules, and without really changing anything else in your application. Or you have an additional client for your business process. Okay. So now customer 2 comes in and can use the same thing. You don't really have to do, as long as they're abiding with the same contracts. Yeah.
Have you introduced the bus are visible, or do you
It is, with OpenESB, everything has to have a wizard. Everything. And even the components, when they're talking with each other, the components could be your connectors, they're called binding components. They're equivalents of the JC adapters in the J2EE world. And they could be like HTTP or SOAP or FTP or SMTP or whatever the component is. they implement WSDLs, and we can see the WSDL accessibility elements in those. The data structures are standard XML. There's a XSD involved, and the message, the bus itself implements. It's based on the JSR 208 JCP, and it implements something called Java Business Integration, JBI, and the messages on bus are normalized. The bus itself is called NMR, the normalized message router, and the actual format of everything that goes on the bus is actually the same. It is standardized. Everybody who is talking on the bus is talking the same language. It's the job of the connectors to transform the data from the proprietary format, whatever it is, to the language that the bus understands. And once it's on the bus, that means that everybody else understands what it is. And only if they need to translate to their own, that connector becomes involved, that binding. So obviously, a message bus is a potential solution for smooth integration. So it's a good intermediate. So here it says if green knows blue, we create dependency between them. How to decrease this dependency is obviously this bus, this enterprise service bus. It's OpenESB. OpenESB has all of these. Has contracted services, intermediation, and process optimization. So the services use a WSDL. The WSDL are going to a repository, and we can talk about what that is. The consumers also can invoke a service, but they only will be able to do it using the WSDL. So they're not using any of the interfaces. And again, any of the clients can be, for example, a .NET client, for example. There's no Java binding there, and it's just the same. In this case, we use inside of the ESB, we use the Metro Web Services stack, JAX WS. It's WS star standard, so it's compatible with .NET. So
you're using the consumer doesn't have that, but everything else is plus.
The components themselves are compliant, and the bus itself is
compliant. Services.
Right. That's right. Exactly. Again, the knowledge, reducing the knowledge is reducing the dependency. That's what the bus is. Talk about. Okay, so just a bit about the history. It was designed by Sun Microsystems that I mentioned. Originally as part of the acquisition of Cbion by Sun. I was originally at Cbion. I developed the eGate Java edition and what was called Icon Suite, which was the integration engine. As part of the acquisition, we renamed that to Sun Java Caps. And then at the same time, Sun, as you know, Sun was big in open source and reference implementations. We worked with the JCP, created JSR 208 spec, and implemented the OpenESB based on that for reference implementation. And a product was released using that, called Glassfish ESB, which used Glassfish open source application server as an application server. So as part of the Oracle acquisition, I left Sun and formed Logical with a bunch of other guys at Sun, and we continued doing what we were doing at Sun with OpenESB. And we've created a business around it. So basically, this is some numbers related to that. Just give you a timeline. Where we left it 2009 was there was a Glassfish ESP 2.2. But then we added support for JBoss application server, so JBoss can be an application server instead of Glassfish. Standalone version using JDK, so you don't even need an application server. By the way, all the applications that were built in Java Caps or in OpenESB or Glassfish ESP would run without change, whether you're using Glassfish as an application server or standalone JBoss. Or Tomcat. We're now working on the cloud stuff, so we've got some initiatives related to that. This is our comparisons based on our ideas. You might see different opinions, though. So that's but we believe that our project, our open source product, is more of an enterprise and obviously lower cost. There is no cost really other than support. It's all around the world and many domains. So service oriented, low subscription cost. You can. I'm zipping through this because I want to get to the actual demo part also. But
we have about an hour.
Okay. Basically, because of its
hour left of it, an extra hour.
Okay, extra hour from that. That sounds good. Okay, so let me run some slides about how just. These, I think, will answer some of your questions that was asked. Inside the box, what is it? It's OpenESB Developer Studio. It's based on NetBeans 7.x, 7.3.1 IDE. And you can use any of these application servers or just standalone JDK. It's easy to install. Actually, the whole thing installs in a matter of minutes. And it comes with it. It comes with a bunch of binding components. These are some of them. And also service engines. VPEL is very widely used. VPEL stands for Business Process Execution Language. It's a service orchestration language. We'll go through some of that. Camel, rules, various protocols. HL7 is widely used in healthcare, for example. REST, obviously database. We've covered this. Easy to use. Okay, so this is a project view. You will see here in this case, this is what we're going to show is an echo. It's a like an echo application. So you send something on a web service, and it echoes it back. You'll see the components of the project. There isn't any code in here. All you have, well, you have some whistles. You have a whistle in the echo project, and you have a VPEL. And the only reason why you have a VPEL is you could use it to orchestrate the thing. Otherwise, that's it. And the Echo CA, CA stands for Composite App. It is where you can take a bunch of projects and hook them together. And there is a composite application service assembly editor that allows you to hook up and build and deploy. And the deployable is just a zip file that deploys, to your OpenESB framework. Doesn't matter where it's running, whether it's running on side of a of a Glassfish application server or JBus or just on a standalone JDK, it will deploy there. It will unwrap. When it unwraps, it is a service assembly. When it unwraps, in the JBI you have something called a service units. So service units is unwrapping of the service assembly into distinct applications that are deployed to the various components. So a service assembly, let's say you had an integration project. Let's say you had some file on an FTP server that had some data, and you wanted to pick up that file, and then take some of that data and insert it into a database, and then take some other piece of information from the database, do a query on the database, and then post it to invoke a web service with that. So let's say this was your integration project, right? In this case, there could be your service assembly when you put it together. There would have been a WSDL for your FTP. There would have been a WSDL for your database. There would have been a WSDL for your a web service, right? And then there would have been a BPAL that orchestrated all of that. So when it unwrapped and got deployed, there would have been 3 service units: one for your FTP binding component, one for your BPAL service engine, actually 4. One for your SOAP service, and one for your database. So those WSDLs, and if there was any XML, XSDs would be also exchanged inside of that. And would go deploy there. That's it. It would run. So this is a preview, and then here it's showing the services view, where you can see. It's very hard to tell, but you will see the service engine. You see the Sun BPAL engine and so forth. On the binding component, you will see the file binding, the FTP binding, the HTTP binding, and so forth. On the shared libraries, you will see these are the messaging encoders, your message parsers. You know, when we talked about transformations, you know, all of that is already built in. You don't have to reinvent the wheel for any of these binding components, or you know, you just configure and go. Or any of these languages, you know, they're already there. You can just use it. There's actually an editor. I can show you the BPAL editor. You can graphically create your business process, your partner links, hook them up, and it actually generates the BPAL. And you can go in the BPAL and change it, and you render the graphics. So it's round-trip engineering, and you don't have to write any code. And your messaging coders, you know, HL7 would be another one if you're using healthcare, for example, or Swift, or whatever, if you're using banking. And then your service assemblies, yes?
One question. I mean, the messages based on what you said on the flow to a bus. Is this bus manifest itself in Q bus?
Right. It's the default implementation. It is just an in-memory bus. It comes with the system. Okay. Now, if you want to add persistence, it's very simple for you to do that. Very simply, you can hook up a JMS binding in your orchestration, and then you can persist every message. Or you can just simply turn on message persistence on your BPAL engine for your business process, and it will persist the message to your database. So yeah, you could do either, but in general, the bus itself is in-memory bus, and it connects up all the components.
But then if let's say the bus goes down.
Very good, very good. So you can first of all, you can actually the components. Many of the components are XA aware, and your BPAL service engine is your transaction, XA transaction manager. So for example, let's say you have an orchestration that involves even a non-compliant, XA compliant component. Let's say you have a file binding, involved with a JMS and a database. And you want to make sure that when you read a message from the file binding, right, and it goes to the JMS queue, it's 100% sure that it's committed to the database, or the entire thing is rolled back, including the message back in the file. The FTP or the file binding component, even though they're not XA compliant, they know, they're aware, they know how to do the rollback in case the entire thing is not done. That's one thing. The other thing is there is compensation handling, which is used for more complicated, which allows, other than XA, which is automatic, it allows the developer, whoever is writing the orchestration, to do compensation separately. It does support once and only once guaranteed delivery.
So what happens if you scale it?
How do you scale this? Very simple. First of all, every one of these OpenESB instances, so you can have as many as you want. You can have as many as OpenESB instances as you want. When you throw something at the bus, that specific bus has the components for that specific instance of OpenESB. But you can have as many of them as you want. And if it's coming in as a like an HTTP request, you can use your standard HTTP load balancer, for example, for your HTTP traffic. All the invokes that are happening on your web services can go across the OpenESB instances. If you're using database, same thing, different connections. The connection pools and connections that are handled by the different OpenESB instances. So when you deploy an application to a target, you can deploy it to a single target, or you can deploy it to a cluster target. Cluster target can be an application server concept, or it can be OpenESB cluster concept, which deals with multiple instances.
So this does its own deployment.
Yeah, so you can do it. Yes, that's right. So in many of the organizations, I can tell you that's being used. Yes.
So I'm deciding up to the box. They're aware of each other.
They're not. No, not at the application level. The components themselves would be aware of the other instances, but not the application. The code that you write, the integration project that you write has no idea about that. But the components are internally cluster aware. That's correct. And that is the beauty of it, obviously. But again, when you're building your integration project, you don't have to. You can do it.
One question. So if this can do its own deployment, it can be possible to have, let's say, 3 different ESB worlds, one for development, one for test, one for production.
Absolutely, that's typically what's used. Yes.
Oh, okay. Yes. So you could say, okay, run this in test.
Right. In fact, a lot of the way most companies use it, developer just installs their own OpenESB on their box, and the developer box do their own thing, right? And then when it goes to the integration test, they set up a Jenkins that deploys it to their UAT servers, along the other things, and then it gets promoted. You know, the bundle gets promoted later on to prod. Same code, and they could be different platforms. One could be Windows, the other one could be Linux, and another one could be AX. There's no
automation in OpenESB is, you know, that the promotion across the clusters is done by the OpenESB side.
Well, across the environment you can, yes, and we can show you how that is done if you define it. Yes, that's absolutely one way to do it. But the other way, a lot of places, they automate that by simply using a Jenkins CI. You know, in fact, you can hook up the Maven or Ant scripts that are managed by your deployments. that. Yes, and it's very easy. The same zip file, by the way, that's created for your dev environment can go to prod. There is one other beautiful thing here. There is something called application variables. So in a lot of cases, there are some environmental variables that are unique to the environment. For example, your port numbers for your web services, or your path for your FTP servers or your file systems, or your tool names for your databases and so forth. With application variables, you can give it a logical name, and you can tell it at runtime to resolve that to the actual name. So at that time when the instance is run, the logical name gets translated. So on the dev environment, it's something different as opposed to a production environment. Same code is only using the application variable name value, but runtime resolves that at runtime. Yeah. Questions?
Yes, actually, this bus too. Okay, basically this bus is a JMS memory.
It's not JMS because JMS, by it is a specific implementation, and it has generally persistence as part of it. What I said is it's a bus. It is called NMR, Normalized Message Router, and it's part of the JVI spec JSR208. Now, you can hook up very simply. If you want it to persist it to JMS, all you have to do is you just in here you just add a JMS.
My question is, okay, it's a bus, and then the Google can do the bus is always like basically, let's say you have two data centers.
It's not one bus. No. So as I said, each instance each instance of OpenESB it's its own bus. So if you want to, you can have thousands of instances. Okay, in case of, for example, IFPS is one of our customers. It stands for International Financial Data Services. They are a transfer agent, and the online trading that, for example, happens with E-Trade and many other trading houses is handled using IFDS. So they're just white label moniker like that. And they use internally, they use OpenESB for all of that. We're talking about billions of transactions, or Blue Crosses of state of Washington, state of Utah, state of Oregon use this. For all of their HIPAA trading, the exchange. So between all of their or MDON, which is a clearinghouse for healthcare claims, actually, they use that. It's not just, some of them have 60 servers running this, right? So it's not just and each of the servers, they have multiple domains and multiple clusters within that domain. It's completely distributed. It's not like you have one bus and everything is jamming on this bus. No, it's not like that. And if you're going across, let's say, from one application to another, the different data centers, you're not really talking on the same bus. You're using web services or some other whatever mechanism you want to use. Yeah. Right. WSDL documents. So this is like everything has already a graphical editor. So WSDLs. This is your graphical editor for WSDLs. Your graphical editor for your BPOL, business process. As you see, you got the partner links, your activities, right? In this case, we're doing a receive, assign, and reply. It's a request reply web service that does some assignment. That's it. And assignment, very simply, you could just drag and drop. In this case, as you see, you got a bunch of WSDLs on the left side and on the right side. Part one of the echo in this case, went to this other thing, right? To this other web service, right? But I mean, it could have gone to any of these other structures down there, right? You don't really have to deal with, oh, how do I map an XML from this web service over to a database, an Oracle database? You don't have to worry about that. It's just you're just doing the mapping. Okay. How does it do it? As I mentioned, first of all, in here, everything is a normalized message. So inside the bus, everything is the normalized message, the standard XML canonical format that's on the bus. But the components are aware of the protocol that's used, the API that's used, and all that, and they do the transformation and translation for that. So the database VC knows how to take the XML and convert it to a DB query or a database insert or update operation. You don't have to worry about it. You don't have to code that. Does that answer your question?
Well, that for simple mapping, yes. Yeah, complex mapping.
What does it matter? You're either doing an update or you're calling a stored procedure. In any case, any of these kinds of things are represented in here as a structure. It doesn't matter. Now, if you really want to code that, if you think that it's not efficient, and you want to code that, it's no problem. You could do Spring, you could do just Pojo. There's a Pojo service engine. You can create an AJB. There's a Java EE service engine. Doesn't matter. You could do that. We have folks that are using proprietary object database. We didn't build a component for that, but they have a Pojo that they can just say, okay, well, I'm just going to use the Pojo service engine, and I'm going to drop that class in there, and that's it.
So does it support like the state which is allows you
yes,
to map?
Again, with JPA creates, what does it do at the end? Some jar. You could just drop that jar into the Pojo. That's right. So anything that you already have in existing, or you create that there is no component for it, you can use one of these components, like the Pojo. This is a so I showed the WSDL editor, I showed the people editor and the people mapper. Here is the cost editor. This is what you're using to hook up the various applications together. Composite application service editor, service assembly editor. So as you see here, we got a SOAP client and a BPAL in here. They drop on a canvas. By the way, there's a lot of other features that I didn't really talk about in here. Things like throttling, threading, all of those kinds of things, right? They're called QoS, quality of service. Those kinds of things you'd have to code for or try to figure out if you're coding. In here, they're configured. So you can actually set up throttling so that if you've got, let's say, going downstream to some web service which is really slow, right? You don't want to flood it. You can actually limit how many messages are pushed down in so many seconds by just configuring QoS. In here, I guess we're just showing a WSDL. Sorry, we're showing a message. This web service is just going to echo. I guess it's the echo web service. Is just we're gonna send an XML with some payload. The payload has my name in it, and it will echo it back. Anyway, we can probably show this in a minute. Just wanted to, we talked about many of these, but it's based on standards. You've probably seen a lot of these standards already, right? Any questions so far?
Well, all that was running in NetBeans?
Yeah. So the design time, the developer studio is NetBeans 7.3. But the runtime, as I mentioned, can be anything, right? Can be a standalone JDK or one of the application servers I mentioned.
But all this visual, all that.
All of the tools are NetBeans plugins. Yeah. So when you install OpenESB, it installs its own NetBeans version. So it already has the plugins already booked into it. You don't have to individually install the plugins. So there's a lot of plugins like your VPL editor, your WSDL editor, your CASA editor, the extensibility elements for the WSDL extensibility elements plugins for your binding components and service engines. And all those things are plugins, NetBeans plugins that need to be there for that to happen. Also, when you go to deploy, under the services tab, you can go and deploy service assembly and so forth, right? That's also a plugin. Can run on any of these platforms. I mentioned some of this, .NET and so forth. So really, it doesn't really matter what kind of language and so forth you use.
So you showed that the REST was structured that this would be accept.
Yeah, there's a REST.
At odds with SOAP. So how do you
No. There are two separate components. We've got a SOAP, HTTP/SOAP binding component. That's one of the components. Another component that we have is a REST binding component. That's another component. As I mentioned, there's 50 plus components. There's a FTP binding component, SOAP, REST, VPL service engine, Java EE service engine.
have a WSDL.
Remember, the component itself does the mapping between the API that specific component is understands and the standard JVI spec. It provides a WSDL interface, the standard WSDL interface that with the extensibility element that the bus uses. So when you create an application using the REST, you're not doing anything different than if you were doing it with HTTP or FTP file, because the component itself will do that work for you.
So I have a question. So all the what I would call like parallel facing components, right? The components are talking to each other, right?
Through the bus.
Through the bus.
And using the WSDL.
They're using WSDL, and WSDL is a very restricted spec, so it has all validation in it and all the specifications. So you cannot like pass any kind of garbage because essentially WSDL will like reject it. You cannot. It just won't work. Okay, so it's baked right into the XML itself, right? However, like you say, your RESTful interface, and even less so, say file or reading some kind of other system. The data can be anything, and yet
sure.
you're so it's completely open, right? It's not
That's
locked
right.
down for,
That's right.
for WSDL.
So what happens?
How do you handle it? Right.
So the component itself, when you create your orchestration, you also have fault handling. The component, you can say what happens when a fault occurs. You can, for example, set up an alert, reject the message, put it back in the queue. You can do these are part of the compensation handling that you do. The components will know that something went wrong, and the component will be able to report back to the orchestration engine that okay, this message something went wrong, it needs to be rolled back, and it needs to go into error queue or some other thing. That's what happens. And so it's not like before, if you're coding yourself and okay, well, I'm gonna, either it just zips through it, bypasses it, and it gets in as garbage, right, into the database, or they have to specifically put. You would still have to handle more generic way fault handling related to that, or compensation handling related to that. Yes, but it's not at the level of a very new level. It can be. It's not.
Are supposed to support
It can be. It does not have to be. Now, you would if you're using XA, you can use one of the components within an XA transaction. If you have, let's say, 4 kinds of components, 3 of them can be XA, and 1 of them does not have to be XA. And it will take care of the rollback. Because the components themselves are aware that the message has not, if the XA transaction doesn't complete successfully, it will modify the FTP or the file PC binding component will know to roll that message back to file. You put in specific coding for that.
But let's say I write in REST,
you're writing, but you're not writing REST. You're still using the REST binding. You're not writing any of these components, right? All you're doing when we go, all you're doing is you're configuring a REST role, and you're putting some XSD, and you're creating your partners, and you're hooking them up in your GitHub. That's all you're doing. Right. So if you're using, you can obviously use Clojure. You're using your business rules and Clojure. You could use these rules in your GitHub. You can use, and you can handle composition and then GitHub, whatever. You can, if you're using tools, for example, for your rules engine, there is a tools service engine that will just simply take in your rules project and execute it. And it will, it allows you to make that part of your orchestration. That one we don't have, and we'll love some for somebody to
Because that is the only
if you're good at NoSQL and you'd like to write code, the code is the open source repository on Bitbucket. Will have that. Yes, there is a Clojure service engine. Yep, there is a Clojure service engine, and it will take any dog class for the dog. Yeah. So I mentioned when I mentioned that I have to tell you that there are certain cases where that's not going to work. In the case of Java, if you're doing all kinds of good stuff, they may not be able to roll it back. They may have to do it. So, no. I have. It's tell you how it's done. There. So FTP binding component has a before and after image. And it uses the rename operation to roll back. Same thing with the file binding. So it can roll back the message by renaming back the just
It's go back and watch this.
no. So normally you will not have more than one non-XA compliant component in the mix. Right. If you do have that, you probably have to do additional coding in what we call compensation. You could do that in your people process. You can say, okay, in this case I will fault, but I get this fault, I gotta do this other thing as well.
So if you want to roll back and watch this, you can say, I'm sorry you
Oh, exactly.
No.
Yeah. You said if XA compliant has to come back.
Oh, okay.
No, it goes back silent.
Okay,
Yeah.
exactly.
It has to go back to
I think this might answer some of your question. You mentioned about how does this happen? Well, obviously clusters. So each of these are instances. Each of the operations are instances. So really, you can have 1,000 of these if you want. I mean, just fire up another VM or fire up another cloud EC2 or whatever you have. Yeah. Remember, each of these instances has its own bus.
The receiver is now capacity for this cluster to
So again, if the web service that you're going to, or whatever the database that you're going to, right, is down, okay, so this, and there is no alternate path. Obviously, this is true. This is going to throw a fault, and it will retry. It will retry. It will continue retrying. Depends on your BPAL or on your. You can actually specify how many times the message is retried. It will retry that many times, and then it will throw a fault. So, and you'll be able to see there's a fault. So what normally happens, obviously, in many cases, the way it's written, a lot of people use a dead letter queue. They throw in a JMS component, and they make it go to a dead letter queue, and then they have some JMS client that some administrator uses that is able to move data from the dead letter queue to the real queue. And by the way, the dead letter queue is actually a concept within the JMS binding. It knows about. I'm not going to go through that. I think this is more marketing. Okay, I think we talked about this. That's basically XA. This is pretty much XA. You can say it's this is configurable. You don't have to. Throttling, I mentioned throttling. I think already. Message redelivery, I mentioned that. So redirection, process persistence. Sorry.
Process persistence.
Okay, so you can actually tell the beacon engine that you can turn on persistence on the beacon engine. When you do that, what happens is that every beacon process, everything that happens within that beacon process, all the activities all the variables, everything is actually persistent to database. It's going to be a bit slower.
I mean, it's kind of logging.
Well, actually, it's more than that. It's a little bit slower, but it does two things. One is what happens if your machine drops dead? Right? You cannot unplug your machine, right? When you plug it back in, it knows exactly where that that activity was. So let's say you had a 20-step business process, and you were on the 6th step, which was FTP to this server, right? It will not replay from step 1 and redo all of that. It will actually start from step 6. That's what it will do. Automatically, you don't have to write code for this.
Well, that means that partner services that engage or statements.
Well, you have to, and that's again, when I talk about compensation handling, if your web service or whatever was, the ones that you're trying to use, right? Your external systems, right? Aren't gonna be able to handle that. You have to not use that. I mean, in the case of MDR, for example, when there was a lot of cases like that, and they, because of that, they did not use default systems. Because it wasn't because it was that OpenESB was fine. It was just other systems couldn't handle it. So what we did in that case, what they did was they threw in a bunch of JMS stuff in there, and they did what they call, fire and forget kind of thing. And then they had an elaborate orchestration engine that basically did error handling process, and it knew where things were and what to do to actually, in some cases, it had to cause an undo operation on an external service. So,
What is compensation?
compensation?
I mean, don't say money.
Compensation handling. That's what I was just talking about. Compensation handling means that there is no automatic way to recover from the error, and you have to actually incorporate a compensation handler to deal with that. Which, an example being, you actually maybe have to cause some other thing to run on an external service that's not part of the system to roll something back. XA support I mentioned. Okay, I think we talked about it. The important one is once and only once delivery, which is supported. Obviously, for trading and bank and healthcare applications, you couldn't have that. And by the way, it's also used in telco extensively. A lot of the MVNOs, multiple virtual network operator providers, I don't know if you know what they are, but they are the local operators that provide cellular minutes to end users on on these cards, like without contracts. Well, the local operators don't operate the network that provisions the cell phones, right? OpenESB is used to hook up to, for example, to the Vodafone network by the cellular local in various countries, Belgium, Turkey, Egypt. And the cell phone provisioning and all that happens using OpenESB, and the billing and so forth. I mentioned you can see all the various social networks related to that novel in OpenESB.net. I have a bunch of links here. The OpenESB Jenkins instance, all the builds, JUnits, driver test units, which are composite apps are there. The issue tracker, Jira, the wiki pages. That's what's there. There is some stuff that's obviously logical. The logical distribution is obviously the gravy that you get. There's enterprise monitoring, tracking, various other things that you get, cluster support, all that security, those kinds of things that are not in the standard community distribution. Those are more enterprise features that are used by the customers, by the paying customers that subscribes. I mentioned it runs on multiple platforms. The components themselves are OSGI compliant, but there is some work to be done on the framework here. That's still work in process. But you could also deploy it. I mean, right now we have ability to deploy to the OSGI container, let's say to a Glassfish before or a Felix, and it would work. So, very key point at the end. The artifacts, your composite application zip files that you assemble, doesn't matter how you created them. You use the NetBeans IDE to create them, but they can be deployed anywhere. Doesn't matter. It's an OSGI, it's a JBoss, it's just a JDK, or whatever it is. It's the same thing will run anywhere. You don't have to touch it. Yeah. Sure. Yes, that's called standalone.
Yeah, but it doesn't say JDK. The second question.
Yeah, that just so the terminology. If you ever go on the website, on the open source website, the installation that you would download would be the OpenESB standalone. That is the one that doesn't require any application server, and all it requires is a JDK.
Second question is, what if I just want to write orchestrations or write stuff that uses OpenESB?
Oh, instead of NetBeans.
Did you guys document?
There's absolutely, look, all it is just a file, like, you know, I mean, there is, what the plugins give you is, for you know, if you're using, let's say, one of the components, right, there is a WSDL extensibility element that, for example, you have to specify, let's say, port address, or, you know, what is it? So those kinds of things.
But let me explain something.
Yeah.
I don't know if you guys make it easy for the developer.
You can actually go and sorry, go ahead.
I was on a team that was, we had to create our flows.
Yes.
And we didn't like using flows.
Sure.
But the website had a lot of documentation, a lot of the things that were wanted. It's really excellent. Did you guys understand a little bit?
Right. We have not written that documentation, but what I can say is this: it's if you just take one project, zip file, you can just pick it up and then, you know, and you open it up in any editor, you can simply tell. It's very simple to tell. So all you have is some WSDL. The XSDs don't really matter, right? You have some WSDL, some XSD, some possibly people, something like that, right? So the WSDLs that you have, you know, you can open it up in the editor. Just use one that's there from before. Just see what it looks like, and the extensivity element. It usually is very self-explanatory. Like, for example, it says address, and in the address, if it's a file binding, it's really a path, you know, to a, you know, file system. If it's a HTTP binding, right, it would be a port number, you know,
Yeah,
so operation name.
It would be really nice if
No, the thing is this. You're absolutely right. There is some documentation. I tell you, there is some history on this. We had some things when we were engineering this, while at Sun, and we had a wiki that was part of Java.net. That Sun, everything that Sun had was open source stuff, was in Java.net. But what happened was, when Oracle took over, about 8 months after that, they moved the stuff to some other server, and then they didn't move everything. And then later on, they even shut down the wiki 2 years back, 3 years, now 4 years back. So we have a lot of them we had captured and we put on the site. We have, for example, documented in a lot of the binding component documentation. It actually talks about the WSDL extensivity. But I cannot tell you if all of them is still there or not, and I don't think everybody uses it. I think most people are just using the NetBeans plugin that comes in, and they don't do it that way. But so we haven't really spent the time to go and look at everything. But I think that's a good thing to do if it's not there. But I don't know much. All of this stuff. Just remember, we're not Sun, right? We're a bunch of guys who had families that said, okay, we're gonna skip from Sun and start from scratch with nothing. And fortunately, right now we're doing better. But honestly, a lot of these things, there isn't anybody asking for it as a customer sponsoring it. So it doesn't get a lot of things. But we'll see. I'm gonna go take a look afterwards, see what is there that maybe can be put on a wiki. And
because when I was doing those posts,
yeah,
it was nice that all of those documents had a page explaining
right.
wiring up your stuff.
Right.
I think if you have that and even some recipes.
Right. Yeah, there's a bunch of tutorials, but they're centric to using the NetBeans plugins. Now, having said that, the NetBeans editors, the plugins that we create, support round-trip engineering, which means that if you go into the XML view or the whatever view of your WSDL or whatever, right, or just use your VI to edit the file, as long as you don't break it, right, it will be able to render back to the UI, the graphical, and you can go back and forth. And it's not like it's a black box. It's not. The actual GUI is rendered from the actual.
So there's no secondary file.
Right. There isn't any other metadata anywhere else. It's just whatever that file is. So that part you're sure about. And but I think yeah. WSDL tool.
So who ends up writing WSDL?
So you don't have to write WSDL because basically what you do is when you create a project, you can say I'm going to create a BPL project, and then I'm going to say and then you say I'm going to create a new WSDL. Let's say for FTP binding, you're using the wizard for the FTP binding to create the WSDL. You're using the wizard for the database binding to create the WSDL. So it creates the WSDL for you. It uses a template to create the WSDL, and you go and then configure the thing.
Right. So when you write your is the orchestrator created automatically too, or do you write one?
So then one of the other things you do, and maybe we can move through that. One of the other things you do is you create a BPL project. When you create the BPL project, it will be an empty canvas, okay? And then you can drop your partner links, the WSDL, in there, and then you can go and do an assign.
Right.
So whatever you can just there is on the palette on your BPL editor, there are activities that you can drag and drop to the canvas, and you can just hook them up. You can do the assignments, and that's it.
Right, I understand that. Yeah. So at which point is the schema compatibility being verified? For example, user service and your consumer service actually are schema compatible.
Yeah. So there is, I think, a check in the plugin that you can say enforce validation.
But that's a design time. What about runtime? is there something that will validate that?
I believe it's. I have to check. I believe there is a toggle for that. Yeah.
Because otherwise, you could end up essentially with a plan that's not executed.
Yeah, I believe if you turn on validation, it will reject. It will actually throw a fault. Yeah. So yeah, it should be available at runtime too. I'm pretty sure. Yeah.
Kind of curious about
Which one is that?
Flume.
Flume, no.
It's sort of like a, I don't know, kind of want to call it. It's not a clustered application server, so it's maybe it allows you to deploy one of the individually for you to do that sort of mesh it all together yourself rather than yourself.
I see.
I was wondering how you could.
I haven't looked at that, but does it actually have all of the ESP features that I just talked about?
No. Doesn't.
And does it have the connectors, the components?
It is like a connector. It's not.
Yes, but remember, there's 50 plus connectors here that you don't have to write.
Right.
You can just.
There's a whole bunch.
Oh, they have.
But it is new. It's relatively new.
Okay, so one thing I can say about this is this code is not new code. Okay, so what happened was CBeyond got bought in 2005 by Sun. Before that, there was CBeyond for another 10 years before that. I started January 1st, 2001 at CBeyond when I wrote the eGate Java edition. So the actual code for the connectors have been running since 2002 in various big organizations, hundreds or thousands of organizations. They were refactored, they were open source and refactored to the JBI spec, but they're not 100% brand new code. When you're dealing with legacy kicks or whatever it is, okay, whatever you're dealing with, right? There is a lot of things, that accounts for it. So somebody who comes up today or last year comes up with some new thing. I know JBoss has been working on SwitchYard for 4 or 5 years, but they don't have any other customers that they're JBoss. So it speaks for itself. Code that's been running in production for years by big enterprises has been exercised. And all these components aren't just developed by some guy yesterday.
So I think that it would be possible for somebody to write an ESP with Flume, which is very strange. Yours has the whole thing packaged together nicely.
Right.
It's more like if somebody wanted to write an ESP, they might.
Okay.
But I'm not.
Well, I don't know. I don't know.
That's not too bad, though, because look, the Excel part. How to do it? None of these components are Excel components. What are you talking about? I mean, the big thing here is this Excel components over many components that are not databases. They don't.
That's true.
It is very difficult. I mean, I tell you, when you ask me how is it done for FTP or file, I told you, okay, this is the way it's done. But there is a lot of intricacies, like database, this, that. There's
here is this the Excel compliance.
and that's not the only, that's only one of them.
That's one of them.
But
Exactly.
threading, imagine threading, imagine clustering, imagine just there's many things, right? You want to architect all of that yourself.
I'm not trying to be unfair.
No. I'm just saying, this can take a lot. When you really think about what's inside, right? Or threading.
But honestly, the training and the solution, many frameworks have achieved it. One thing that actually has not been cheap because it's a challenge. It's the XA part, components that are by nature what databases are not really supporting executive. That's a big challenge.
Yeah. Yeah. Any question?
Related to this, and this is a very broad question here, but I kind of think about services and how you work. Like how I would normally approach a project, be following the REST principles that we're learning now, and creating REST servers in JSON, and maybe orchestrating with something like SQS.
Okay.
So I'd like to hear is more clear jumping off from there, where do you switch to this? At what are the business requirements or complexity requirements where you go, all right, now we need to move it.
Right. So
there's constraints involved in this, and there is a lot.
Right. Well, so I mean, if your business, right, only had 2 partners to link up, and that's it, and you would never have any other one, and it wasn't going to change a lot, obviously I would not invest the time in the ESB. Okay. But just imagine, once it goes between more than one protocol, more than one message structure, multiple partners, things will not be static, or they will be changing. There is performance implications, there is standards in play and other things, skill sets, all of those things. Then, right, an ESB might have to be in play. And in a lot of cases, it does help because the thing is this. Now, by the way, just traditionally, ESBs were not cheap. You look at TIBCO and Oracle Source Suite and Web Methods or IBM, whatever it is, all of those guys, they're, you can be spending hundreds of thousands, if not millions of dollars. I'll give you an example. Cambia Health Solutions was paying Oracle $4.5 million. This is truth. $4.5 million without services, just for support and licensing. A year, $4.5 million for Java CAPS license and support. Okay. So, and what happened was Oracle. They were not. They didn't stop using Oracle because of the money. They called us because they weren't happy with the support that Oracle was giving them. So they called us and said, "Can you help?" And we said, "Okay, we'll help." So we helped them with Java CAPS and all that a little bit. And then later on, and they said, "Why don't you just switch to OpenESB?" And they said, "What are you guys? I mean, Logico, Cambia, all of the various states, Blue Crosses in various states. Obviously, that doesn't make sense to them, right?" So that was fine. That was fine. Now, about 8 months later, I got a call. Said, we're rethinking, right? And this was about 2 years ago. So then they said, "So what can we do? How easy is it to do it?" I said, "Look, we'll do a POC project, 6 weeks. It will cost you $20K.
You should have said $2 million.
No, wait. It will, honestly, God, I said, it will cost you $20K, and it won't be all our costs, just, and I'm willing to start it on the same boxes that you have, no new boxes, right? So all we do is just figure out the ports and all that, and we did. We said, give us your 10 projects that are in Java CAPS. We'll convert that in this POC program on your sandbox, on your systems. Let's do it. And we did it in a month. We did it in a month, and then obviously they switched to us, and they've been running in production for 2 years, 2.5 years, with us. How much are they paying us? We're talking about. No, I mean, so we're talking about for their many servers and so forth. It's definitely way less than 100,000. So they went from $4.5 million to less than 100,000, and we give them 24/7 support, right? 1 hour response, and they had memory leaks, they had issues with connection pools, so forth, that would only be reproduced every few months, right? That we fixed we found them fixed. So they're getting their money's worth. Anyway, so I'm saying it's open source. You know, the ESB. A lot of people say, okay, well, why should I use ESB? Because it's expensive. No, it's free. That's the point. It's free, and maybe if you got more than 2 partners, you got different message formats or protocols, use ESB. It's free.
There's ESB space and there's new service mix, whatever. Would you describe yourself being in that mix? I mean, in that space, you know.
I had a slide actually for that, which showed Mule and some of the other
No,
ones.
you listed the names,
Yeah.
but I was going to say that.
Well,
what would you say is
That slide was the higher up and more expensive.
Right.
Oh, okay.
Right. So there is no cost. There is no license
No,
cost.
I'm assuming that
As far as features,
it's like what do you emphasize?
from a technical
What do
standpoint.
you emphasize compared to what other people do?
Okay. So one of the biggest advantages of OpenESB, a lot of the ESBs out there are basically message routing engines. When you look at TIPCO says we're an ESB, they're not an ESB. They're a message router. They're not. The contracts between the components and the services that they create using the ESB tools that they have is not based on standard contract. What we do here is contract first. Everything is based on a contract. So the fact is that maintenance, and that's why I put the slides the way I put them, is if you're using Mule, if you're using Spring Batch, if you're using any of those other products or open source things, because they have no, maybe they're a bit more flexible right up front because they don't force you to create a WSDL, right? But then that you're going to pay for that down the road. But all of those things will cost you more maintenance, and they're not standard. That's the thing. This is completely pure Java, organically created. There is nothing in there that is from somebody else. Everything is open source. I mean, even Mule is not all open source. Whenever you talk about many of these, what they call themselves open source, Fuse or what is that? WSO2. Go try and use WSO2 for real in production. You're going to be paying hundreds of thousands of dollars if you have a real enterprise. And many of the other ones, even Mule, the enterprise features of Mule are not there. What Logical has in that case, as far as value add, is not what you need for running. It's basically what you need for management. So you can use the community version of OpenESB in production. And if you want to have your own enterprise tools for monitoring and alerting and message tracking and so forth, obviously you can. What we in addition to support, right, revenue that we get, we also added some bells and whistles for these kinds of things. And obviously the other real reason is also just so that I give you some business secret of ours is, obviously we have the bulk of, pretty much all the productions OpenESB users are Logical customers. So obviously we know about all the problems in the code, right? We fix them. Even though we contribute the fixes into open source, it doesn't come out immediately. It comes out in the next release, and it's bundled with all the other changes, with the community changes. So there is a risk if some organization wants to use it in a high-profile production environment, they're a big enterprise, they don't want to take that risk. They want to go with us so that they know, because we can give them a patch. We have thousands more JUnit tests and driver tests that are run. And obviously, we've got the bulk of the already known issues with the various versions that they have. They don't have to upgrade, right? So we can give them a patch ready. Yes?
I was going to ask about things aren't working right. What visibility is there into what's happening right now, and then what happened yesterday?
Sure. So obviously there's log files, always, right? You can always, go back to log files that what's going on. What's happening right now? That's part of the enterprise tools where you can look at the beeple instances. You can see what messages are going through, the timestamps, and so forth. You can look at the faults. You can dump out the variables. There are things, definitely facilities there that you can use to do that. If you really want, the beeple engine, there's a debugger port that you can use to attach in real-time debug. There's all kinds of facilities. It just depends on what. But in general, you would look at the log file and look at severe errors in the log file, and try to see from there what could be wrong. And sometimes it's not easy, like always, but that's the case with any code.
We're having a problem with service bus
Yeah.
where it's taking too long. Things happening should take 300 or 400 milliseconds. It's
Okay.
taking over a second. And I did the best timings I could. I could only tell where half the time was going
Okay.
through 7 different service components.
Right.
And it was really hard to distinguish which was this transaction versus all the other things interspersed through the log file.
Sure. So another tool that's available is called a thread dump. I don't know if you've used that. Sorry, you're on.
WebLogic Oracle.
Right. But even with Oracle, I don't know about it. I don't know about that. But in general, with OpenESB, if they're running on Glassfish, for example, you can do a kill -9 and get a thread dump.
So that's a snapshot in time.
That's perfectly good, right? So if you've got a couple of snapshots, you can compare the snapshots and you can look at the waiting threads and the idle threads and the block threads, and you can tell what's running, what's happening. We've been able to, many cases, performance issues like that. We've actually been able to use the thread dumps to figure out performance issues. That's right. That's right. Now, the other thing, as I can tell you, is that the enterprise tools that I told you is, and I don't know if we're not going to have time to go through all that, but I'd like to show at some point the monitor that we have. When you do a tracking, actually, the beeple process, you can actually drill down on an instance, and it actually renders the SGI graph of the business process, all the activities, and how they're hooked together. And as the message is flowing, you can see the timestamp going into each component coming out. It's in milliseconds. It will actually show you how many milliseconds, right, was consumed within that component, right? A lot of times, what happens is that there could be a thread pool issue. So, for example, you're doing a database insert, right, and you don't have enough threads on that database connection, and so it's waiting for a thread to become available. But a lot of cases, like if you're calling a web service, you don't have enough HTTP request processing threads, and the beeple is trying to wait for a thread to become available to do it. There's all kinds of things like that. You can find out with that. Does that answer?
That's just related to that, though. One of the things that but they had in their service-oriented marketing, they have SLAs on how fast it will take them. Does that have anything? Could this enforce maybe in the enterprise, like enforce SLAs or at least reports?
Yeah.
Hey, this is supposed to take, like you say.
Absolutely. That both IFDS and Cambia Health Solutions, the group process, they have very strict SLAs. That the claims that go through have to get done, go through the various gateways in the middle and have to get done within a certain amount of time. They get penalized if they're late. Yeah, so it does. There is mechanisms for SLAs in here. Now, again, to do that, you have to incorporate it into your application. So you can set up your beeple process where
the orchestrator, I would think that in some
No. Yeah, absolutely. In your orchestration, that's right. You got to timestamp things, and usually, I mean, you could use, if you're using the enterprise tools, you could use the BPEL monitor that, or the message check for that. But in general, it's not going to give you a dashboard. It's not a BI tool, and you probably will need you'll need to throw in that kind of statistics into a database, right? So, and you can use a BI tool that can give you between which hours, what percentage were this, took this many seconds were above average or whatever it is. You know what I'm saying? So it does require, I think, in general, some additional additions into your people orchestration to do that. Yeah.
So does OpenESB support?
There is a Camel service engine that you can use. And,
What service engine?
Camel. Yes. So in the sense that there is a Camel service engine that whatever you do with whatever you can do with Camel, you can do in OpenESB.
So how does that work?
It basically
You just routes at the endpoints at the periphery of the camel route.
right, and you can add additional routes using OpenESB. So there you go. You can actually integrate your Camel project inside of OpenESB as one of the integrations. So when you build a service assembly, remember FTP, REST, so file, database, any of these things, right? Essentially, any of these things are components. So is your Camel service engines or your Glue service engine. And you can create a complete composite application that includes all of that. Now, remember,
With the control.
That will not. The Camel itself, the Camel service engine, the messages become normalized on the bus.
Right.
But what's inside of that Camel project and what Camel is doing is internal and black box and not exposed. The endpoints out of it is exposed to the bus, but not all the internal stuff is not exposed. How can it?
It has its own business. Basically, it looks like a black box. It looks like a yet another.
Yeah. So there is input output that's inside the window. It looks just like an endpoint, right? But
The
internal.
camel itself would have the whole camel route. That's the way it's-
Right.
Yeah, it looks like a has a component.
I can do at some point, we can do a show of that. How much time we have?
Hold on.
MacBook Pro doesn't work.
Okay.
My machine's ready.
Okay. So anyway, well.
You know what? If you see the value of the audience and coming back and elaborating this real.
Yeah, we didn't get to do an actual demo.
If you'd actually get to build something and show us how it works,
Right.
I'd like to.
Right. I was thinking that we would do like a bunch of things, like an echo service and something that involves a database, FTP file, whatever it is, right?
Well, we could when you back that, but it wouldn't be.
That's absolutely fine. No problem.
By then we could. I will know how to do the Hangouts more effectively.
Yeah,
So-
and then I'll get it. I'll get
So
something
what
that I
we
connect to.
what we could do.
Yeah.
So what I would suggest you do then, you work on a presentation that covers what ESP is conceptually, 15 minutes. That way, if somebody shows up, they're not
Right.
lost.
Right.
And then go over implementation because
They can do something.
Sure.
I think people will actually welcome that. What is audience?
Yeah.
The thing is, the way the schedule is right now, it looks like I think it'll be August or September.
I think that's perfectly fine. So I'll let you let me know, and then whenever it works out for you.
Thank you for being a pioneer and being the first one to have a broadcast for LA
Oh, thanks.
Okay,
Yeah, sorry.
This can be replayed, but we had a really shaky beginning. We didn't have the slides advancing on there
Right.
in the beginning. It was when I told Hangout to to screen share PowerPoint.
Yeah.
But then when we moved to full screen PowerPoint, it didn't pick that one up.
Right.
So we had to actually tell it to screen share the desktop so that it would pick this up.
Right.
So the beginning was, I felt really bad because it didn't go close to perfect. Not even close.
I do have a question from you guys. That any of you guys doing any kind of a integration project that you're looking at some either open source or product, both proprietary product, enterprise service bus or ESB or integration engine?
We should be, but it's a hard political sell where I am. But certainly we should be doing something. So we usually
Are using it.
Yeah. Yeah, well, Mule has done a really good job. I mean, they obviously have money, and we don't have any money at all. They've obviously got venture capital. So, yeah, obviously that's why they get in with. I mean, we have a lot of.
There's ways to do that socially and just being really bad at HTML.
But it's interesting that you guys embraced OSGI and shifting it like category and like never.
I don't know why. I mean,
Their
to us,
founder just doesn't like it.
you know, to us, maybe it's just difficult for them to. For us, it's already there. It's already there. So the thing is, you know, that's basically it. So I don't know. I mean, a lot of times the vendors reject something because they just don't know how to do it, or if they know how to do it, it costs too much to do it.
Probably. Although I would say that, you know, with something like this, when you have like dynamic services that come and go, it kind of becomes sort of problematic, right? When you have a route, OSGI, you know, you have resources that can appear, disappear dynamically. So how would you do with that, say, when you construct your orchestrator? Something that you're orchestrating is not big. They have to do.
Well, no. So you're talking about like a service that may not be responding, it cannot invoke?
No, it just disappears. I mean, it's like, you know, in OSGI, service can appear and disappear.
Okay, I understand. But remember, the thing is, really, the OSGI in our stuff is really OSGI is like an execution engine, just like Java is. In other words,
It's a container.
yeah, it's a container. So it makes it so that you're not dependent on a specific application server or a, you know, other. If your enterprise wants to do OSGI, it's fine. I mean, we're using it as a container. We can run it. That's what we're using it. But as far as the what you're talking about, services going in and out.
Service is only available, say, from 3 to midnight. Like we have that.
Right. That's fine. There is I'll answer to that right now. There is a scheduler binding component which is built using Quartz API, and you can configure it just like you configure Quartz.
Quartz.
Yeah. And you can configure it just like you configure Cron or whatever, and yeah, that's fine, no problem. I mean,
so you could do things like, for example,
whenever
from 6 to 3 route to the service, and after 3 route to the file or something.
Yeah, we need to wrap up. Okay, well, thank you. May I give you guys a card and is that going to, I can help. By the way, we can help with your POC. So it depends. If you have something you're not sure, your organization needs help, doing the ESB project, and you don't want to spend money, we can help you. We'll do some of that and help you guys. So let me know. And all right.
How do I get it off of you?
Thank you, Fred.
Thank you so much. I appreciate it. Next time I'll bring a different.
Okay, thank you for coming to LA Jug. See you next month, and I'll try to edit the beginning out of this. And then we see it. This will be the end of our presentation.
Stand that way, you can't see your face.
Well, yeah, but I'm looking at the camera here, so.
There was something that